On this video we're going to see how to simplify expressions that are the square root of a square. Okay, so every single time that you have the square root of a square, you're going to be able to simplify this. Okay, so just a quick recall, right? So when you have a positive number and then a negative number, or positive 2 minus 2, you usually say that those two cancel out, right? Positive and negative cancel out into 0. Something very similar happens when you have a multiplying 2 and you have a dividing 2, right? Or 2 divided by 2. You also say that those two cancel out, but those two cancel out into 1. Okay, so now you can also have the opposite operation. You have an exponent, and the opposite exponent operation of an exponent is going to be a root, and those also cancel out. So exponent and root, if they have the same index, they're both square roots, right? They're both cubic roots, then those two cancel out, and they cancel out into the radicand. And I'm going to include the absolute value bars in here. Okay, so the radicand, whatever's inside the root, that is going to be the result. Exponent and the root cancel out. You can think about it that way. Okay, so how are these expressions going to look like? Okay, so for example, square root of 81 x to the power of 4. Okay, so let's see if we can simplify this. This is a square root, so I'm going to try to find a number that when you multiply times itself 2 times, you get 81x to the power of 4. Okay, also what you can do, and what we're going to do, is we're going to try to rewrite this expression. We're going to try to rewrite it into something that looks like this. Okay, the square root of something square. Why? Because then we're going to cancel out the square root and the exponent, and the result is going to be whatever's inside the parentheses, or the remaining radicand. Okay, so let's see if we can transform this expression into something that looks like a square. Okay, so something that looks like this. So let's start with the number 81. What is 81 the square of? So if I want to write this as a square, I should write 9 square, right? So 9 times 9, that's 81. So I'm just rewriting this expression. These two things are going to be the exact same thing. Okay, these two expressions. So that's 81. That's the same as 9 square. And then x to the power of 4 is the square of what? So what times what gives x to the power of 4? You can see that if you take x squared times x squared, multiplication of variable, you have to add exponents, you get x to the power of 4. So it looks like the square root, or well, we're not taking the root yet, right? But the square root of x to the power of 4 is going to be x to the power of 2, or x squared. So can you see that all we did is rewrite the expression as a square? If you want to get rid of the parentheses, right, 9 squared, that's going to be 81, and x squared, that's x to the power of 4. We're going to get the starting point. Okay, so it is important to rewrite the expression as a square so that we can cancel out the exponent and the root. Okay, and this is what we're going to do right now. Cancel out the exponent and the root. Cancel out the exponent, cancel out the root, and the result is 9x to the power of 2. And I have to include absolute value in my result. Remember that the square roots, they are never going to be negative. The result is never going to be negative. So that's why we're going to include an absolute value bars in here. Okay, and the absolute value bars, they work as parentheses. So on this case, since the 9 and the x squared are multiplying, this is going to be the same as the absolute value of 9 and the absolute value of x squared. Okay, so in this case, what I can do is I can simplify the absolute value of 9. You know, absolute value means get rid of the sign. Get rid of the sign. So absolute value of 9, that's going to be 9. And the x squared, since we don't know what that value is, you know, that can be a positive 1, a positive 2, a positive 3, a positive 4. That's a variable. It can also be the negatives. So we have to leave those absolute value bars in there, because whatever result I get from this, it has to be positive. That's what the absolute value bars mean. Okay, so positive. So this is going to be my result. Always include absolute values when you cancel out the square root of a square. Okay, another different situation. This looks a little bit more complex, but it's in theory it's easier than the one that we just did. Okay, so that's x plus 8 to the power of 2. Excuse me. Can you see that this expression, this is already the square root? This is already the square root of an expression that is square. So the rule says that when you have the square root of a square, you can cancel out exponent and root. So once you cancel out exponent and root, the result is the radicand, which is x plus 8, and you have to include absolute value. This is different than the previous example. These two numbers, x and 8, they are not multiplying, so we cannot separate those into something that looks like this, right? We cannot do this. We're not gonna do this. This is only if they're multiplying, like in the previous example. If they're adding or subtracting, then this is going to be the final result. Right? All we do is remove the remove the root and remove the exponent. Okay. So let's see what this operation is going to look like. Square root of 49, x to the power of 10. We're going to try to simplify. These two numbers are multiplying, so it means that the absolute value is going to reside in one number. Okay, so let's see. I have to rewrite this expression as something that looks like the square root of a square. So first of all, what is 49 the square of? If I want to write it as a square, I have to find out what is 49 the square of, and the result is 7, because 7 squared gives us 49. Okay, so 49 is the same as 7 squared. X to the power of 10, how can I rewrite that as a square? X to the power of 10 is the square of what? Well, if you do x to the power of 5 times x to the power of 5, multiplication of variables, that means addition of exponents. So x to the power of 10 is the square of x to the power of 5. And then you can do the checking, right? 7 squared, that's going to be 49, and x to the power of 5 squared, 5 times 2, that's 10 on the exponent. Okay, so we haven't changed anything mathematically, we're just rewriting the expression. Okay, so once we rewrite the expression, now we can cancel out the square root and the square. Square root cancels out, square cancels out, and the result is just the radicand. And remember that you include absolute value. Since those two numbers are multiplying, it means I can take out the absolute value of 7 and then leave the absolute value of x to the power of 5. And the absolute value of 7 is going to be 7, absolute value of x to the power of 5. This is going to be my final result. Then another example that I want to cover is one that requires a knowledge from the previous chapters that we have covered. From chapter 5.4. This is the square root of x squared plus 6x plus 9. Okay, so the first thing that comes to your mind is, well, this one has a square root and this one has a square root, so I want to take those square roots. But remember that PEMDAS says that I have to add all of those first. If I want to take the square root, I have to add them. And since those are not like terms, I'm not going to be able to add them up. Okay, so this is an addition, and it looks like I'm going to be stuck in here. But if I can find a way to rewrite this expression as something that looks like this, then I'll be able to simplify it. Okay, and on the radicand I have a polynomial. I have a polynomial of a trinomial, and I'm gonna place this into a square. Let's see if I can factor it. Okay, so that's a trinomial, so I'm gonna place the first term in the first square, and then I'm gonna place the last term on the last square. So this middle term 6x, I'm going to split it into these two squares, but I'm not just going to randomly split it. Okay, so I have to find two numbers that when you multiply them, the result is going to be 9, hold this square over here, and two numbers that when you add them, the result is going to be 6, which is the term, because when you add those two squares, they have to add up to the middle term. And you're going to find out that those two numbers that you're looking for are 3 and 3, right? 3 times 3, 9, and 3 plus 3, that's 6. So I'm going to take this 3x, and I'm going to try to factor this out, right? So the greatest common factor of this first was that row is going to be an x, and the greatest common factor of this next row is going to be 3, and for this row the greatest common factor is x, and for the last row the greatest common factor is going to be 3. Okay, so if I rewrite this expression as a factor form, this is going to be the same as x plus 3 times x plus 3. Okay, and you see that these two factors are the exact same thing, so you can rewrite it as x plus 3 squared. And now we have our expression that looks like a square. So when you have a trinomial, it will come in handy to try to factor it, see if you reach something that looks like a square root of a square. And then at this point it should be really simple to simplify this expression. Okay, so you cancel out the square root and the square, and the result is the absolute value always. When you cancel out the square root of a square, the result has to always have an absolute value.